So in the earlier sessions we started the discussion of normal forms. So according to our discussion we are having different categories of the normal forms. Those normal forms allows us to perform some kind of the activities. Okay, so 1 minute. Yeah. And there are certain rules we have seen. Let me recap. So if any relation or if any table is in the first normal form, then it should not contain any multi values. So each and every attribute of that corresponding relation must have only a single valued attribute. Okay, so every attribute value is atomic, or no multi-valued attributes must be there. So there we have seen some example. If you see this table 1, in this student phone numbers we have represented multiple values. So just to convert that particular table into the first normal form, you need to observe, okay, you need to split the appropriate information into multiple values, that's all. Okay, so that is what we have observed in the first normal form. And coming to the second normal form, so one important point there we observed. So if any table is in the nth normal form, then it should be in n minus 1th normal form. Suppose if I want to observe any table in the second normal form, okay, then it should satisfy the first normal form. That is the first thing. And thereafter, if it is if you want to convert any table into the third normal form, then it should be in the second normal form. That is a prerequisite. So before entering any table into the nth normal form, it should satisfy the n minus 1th normal form. That is the fundamental rule. And along with that, if you observe the second normal form, as per the analogy, the table must be in the first normal form. And one more important thing is every non-key attribute must be defined by the entire key, not by the partial key. Actually friends, here partial key in the sense, suppose we are having key 1 and key 2. If k3 is there, k3 is a non-attribute, assume that, then k3 must fully functionally dependent on k1 and k2. No partial dependence should be allowed. Now we have seen one example here. So order ID and as well as order date, customer ID, customer name, customer address, product ID, product description, product finish, unit price and order quantity. Okay, and one important thing I want to insist you on this example, friends. You can take your own example. There is no restriction on that. But my suggestion is, anyhow, your normal forms are very much important. As already I am repeatedly telling, like, you know, these normal forms are for your higher studies or for your placements or whatever the interviews or entrance examinations. Definitely the database management system, without asking the normal form, there is no debate of the strength of the normal form. Okay, so that is what the reason, friends, while learning this normal form, as you are having these rules, along with that rules, my suggestion is better you follow one set of the examples also. Okay, because if you observe the standard examples, after getting some kind of the rule, suppose first normal form means all the attributes in the table must satisfy the single valued or atomic, or no multi-valued attributes must be there. That is the definition. At the moment you observe this example, okay, you can see that, okay, student number, name and as well as the phone number, state, likewise we are having. So just if you observe these kind of the things, okay, automatically you can easily refer. Okay, so with the help of the standard examples, okay, you can easily explain the concept. Okay, rather than dynamic examples, if you are taking, maybe you may end up with some kind of the disturbances. Okay, my suggestion is, friends, always look into this and just you follow the examples. Additional examples you follow. Okay, additional examples also follow, but fundamentally you go through these examples whatever I am giving. Okay, right, for the easy understanding, that's all. And as if you are referencing the second normal form, the definition is all non-key attributes must be fully functionally dependent on the key attributes. At the moment I am talking about this particular table, friends, okay, this table allows us to identify, okay, to identify, so which are all the aspects related to the customers, orders and all the product information. Now at the moment you are considering order from the available attributes, if you are taking order, so there we are having orders and as well as attributes related to this order is order date, customer ID, customer name, customer address. So these particular things are depending on the partial key. Actually order ID, product ID are the common keys, friends. Order ID, product ID together they are the keys. So but whereas if I am observing the details about order date, customer ID, customer name and customer address without referring the product ID, you can easily identify from the order ID. You can get order date, customer ID, customer name, customer address. That is the first thing. And another important thing is, friends, so customer ID if you are considering, customer name, customer address. Okay, so if you are referencing these kind of the conventions, okay, customer name, customer address can be getting, you can process with the customer ID also. And if you are taking product ID, the product description, product finish, unit price, all these things depends on product ID, and they are not at all depends on the order ID. And coming to order ID and product ID together, we are taking out of all these particular non-key attributes, order quantity only depending on the order ID and product ID. Just to observe the convention. Okay, now at the moment you are observing these kind of the notations, okay, so here this as per our definition of the second normal form, every non-key must be fully functionally dependent on the key. Here key is order ID, product ID. So definitely we can say that this is not in the normal form, second normal form. Okay, but it is of course in the first normal form. Now if you are observing the second normal form, partial dependencies must be removed. So at the moment you are talking about this partial dependencies, the partial dependency observes that whatever the order ID, product ID, I am having order quantity, it is satisfying the complete representation, order ID, product ID and as well as the order quantity. But whereas at the moment what I am trying to do is, if you are referencing these kind of order IDs and all, so these things are not at all observing the corresponding dependencies. So what I am doing is, rather than going entirely as a table, as a complete table, just to split the tables, we split the tables. And if you are splitting, product ID anyhow is the key, product description, product finish and unit price, this becomes one table, and order ID, and what I am doing is all these particular things, whatever the attributes I am having, order date, customer ID, customer name and customer address, I am making use with the order ID. So now if you compare earlier table with the current table, in the earlier table you are having the partial dependencies. Now you can observe by splitting all these particular tables into three tables rather than doing one table, we are observing our representation in the three tables, and those particular tables now satisfying the second normal form. Okay, these are all the tables which are there in the second normal. Reason is order quantity fully dependent on the order ID and product ID, product description, product finish, unit price fully dependent on the product ID, and order date, customer ID, customer name, customer address all fully dependent on the order ID. Okay, that's what the reason. If you observe these three particular tables, they are all in the second normal form. And coming to the third normal form, friends, what exactly this is? And if you are observing the concept of third normal form as our as per our analogy, so if any table is in the, you need to get any table into the third normal form, first that should be in the second normal form, that should satisfy the second normal form, 2NF plus no transitive dependencies. What do you mean by transitive dependency? Is functional dependencies on non-primary key attributes. In a simplest way, you can remember that transitive dependency is nothing but functional dependencies on the non-primary key attributes. This is called transitive because the primary key is a determinant for another attribute, which in turn is a determinant for a third. That's what we are saying here, friends. Like just let me explain. Suppose we are having now we are discussing the third normal form, and anyhow the first point is the relation should be in 2NF. Okay, so no partial dependencies plus no multi-valued attributes This is the clause. Second thing is no transitive dependencies. Okay, what do you mean by transitive dependencies, friends? A determining B and B determining C, and if again C determining some kind of the A, which is a transitive dependency, okay, which should not be allowed, friends. A to B, B to C, and C to A, this is what you call the transitive kind of the dependency. And here one more important point we have seen from the example, that is if you observe the kind of the example. So if you consider this definition, friends, in the third normal form, one important point we have seen, okay, so functional, this thing actually non-primary key attribute, functional dependencies on the non-primary key attributes. Okay, so FD is observed in the non-primary key, functional dependencies on non-primary key, it should not be there. Okay, so and we have to resolve if any table, if you want to convert that particular table into third normal form, anyhow the basic requirement is it should be in the second normal form. We know the definition of the second normal form, like no partial dependencies must be there. What do you mean by partial dependency? If you observe any functional dependency, if you consider any non-key, that non-key should fully functionally dependent on the primary key. No partial dependencies must be there, and anyhow it should also satisfy the 1NF according to the definition of the first normal form. No multi-valued attributes must be there within the attribute if you are considering, and it should not be containing like repeated values, or suppose phone number if you are considering within the same row, if you are representing 2 or 3 phone numbers, it should not be. Okay, that is not in the second normal form. Okay, so it is not in the first normal form actually. So the attributes, whichever the attributes in the relation satisfies the atomic or single valued, then I can say 1NF. And the table to be in 3NF, it should satisfy 1NF, and it should also satisfy 2NF. Then only we can process the table for the third normal form. And what is the requirement of the third normal form? No transitive dependencies must be there. So for that we are taking this particular thing, friends. Let me explain with some example. Okay, now solution. What is the solution for this? So if you are referencing this solution for this, actually non-key determinant with a transitive dependency go into a new table. Non-key determinant becomes primary key in the new table and stays as foreign key in the old table. Okay, just by reading this text you may not get the clarity. Let me show you with some example. Third normal form, friends. Suppose from the table we are having in the earlier table also the same table we are considering order ID, product ID, order quantity, and product information and order ID. And how we are changing this is, observe here, friends, order ID, order date. So just if you are referencing the order ID and as well as the order date, and what we are doing is this customer ID we are mentioning, as the foreign key, because anyhow order ID is the combination of the order date and as well as the customer ID, because we are referencing the customer ID and at what date he has mentioned the order, he has put the order. And in the customer table, anyhow, friends, customer ID we are having, customer name and customer address. What we are doing is this customer table acts as a master table for the customer ID of the foreign key in the order table. So order ID is a primary key, order date is also non-key, it is a non-key, and customer ID is a foreign key. And this customer ID foreign key referenced by the customer table in such a way that this foreign key is having primary key in the format of the customer ID, and depending on this customer we are having customer name and customer address. There is no transitive dependency. Okay, so with the help of the customer ID only you can get customer name and customer address. And similarly if you are referencing the order ID, anyhow order date depends on this order id, customer id also depends on the order id, provided for this particular customer id, as we are maintaining this customer id as a foreign key, then based on this particular customer id you can observe the customer id in case of the order table. So whatever the table we are having, now we are removing the transitive dependencies. Okay, so if you consider the actual solution, friends, now you can read the thing. Non-key determinant with the transitive dependencies go into a new table. Here observe here, actually in this table we are having customer id, customer name, customer address in the transitive dependency format, transitive dependency. So what we have done is we removed the transitive dependency. So just to observe here, non-key determinant with the transitive dependency go into a new table. Okay, so this customer address, customer name move to the new table, and non-key determinants primary key becomes primary key in the new table. If you observe this customer id, it becomes a primary key in the new table. Okay, customer name, customer address referenced by the customer id is one table, and of course related to this customer id, how we are managing the customer id in the order table is just we established a foreign key, and by referencing this primary key just we are making use of these conventions, friends. Okay, so this is what how you can observe the third normal form, which is very simple. Okay, so now again 1NF specifies that atomic values, there should no multi-valued attributes, you should consider the single valued attributes. And coming to the second normal form, we are having the no partial dependencies. Every non-key must be fully functionally dependent on the primary key. That is the second normal form. Third normal form, there should be no transitive dependency. So related to this transitive dependency, friends, I have given one definition while observing this particular normal form. Let us recap once so that you can be having the clarity. A transitive is a type of functional dependency which happens when it is indirectly formed by two functional dependencies: student id, student name, student id, marks. So if you are referencing these things, id and name, name and marks, obviously id and marks also related. So that is what you call the transitivity. And if you are referencing the transitivity, so just we have seen some other thing, friends. In case of definition, the rule is very much similar to our transitive rule in algebra. A to B holds and B to C also holds, then A to C is also holds. Then if you are referencing A to B is called as functionally that determines B. So consider three attributes. A functionally determines B, B functionally determines C. If these two conditions are satisfied, then if A functionally determines C also holds, then we can say such kind of the rule as the transitive rule. Okay, but in case of the third normal form, this particular transitive rule should be removed. Okay, that is the definition. Now if you consider the table in the second normal form, actually customer id, customer name, customer name, customer address, but similarly customer id and customer address also functionally determined. Okay, so we have to remove that particular transitivity. So that's how we did this particular splitting of the tables. One order we have considered, and that order id is a primary key and related to the order date and customer id. But one small modification we have done, this customer id become a foreign key of the main table. So this customer id in this particular order table is the foreign key, friends, actually. Okay, foreign key, so just let me give the properties of this particular foreign key. Actually we have seen that. Okay, so the foreign keys, so if you are referencing these particular kind of the things, okay, let me give the foreign key properties. So the first property is, friends, refers to the primary key of the master table. That is the first thing. Second important thing is all inserts depends on primary key of the master table. all deletions of the master first deletes the dependent or child, okay, then only you can delete the master. This is the reference, friends. So whatever the value I am having in the child table, okay, it should referenced by the master table. So only the values which are there in the master you can refer. And similarly, if you observe the dependency, okay, all inserts depend on primary key of the master table. Whatever the insertions we are doing in the detailed, first you should refer in the main table or master table, then only you can insert into the detail. Similarly, if I want to delete any information from the master, okay, as dependents are there in the child table, first you need to delete the child information, then only you can delete the master. So that is the relation. So remember, friends, in case of the third normal form, so just there is a concept of the master child relationship, and you have to consider one of the attribute as primary key, and another attribute in second table should be considered as a foreign key. So in this example, we have taken only order table and as well as the customer table. Okay, based on these particular two tables, we established a foreign key relationship, which is nothing but the referential integrity. Now, if I am talking about the customer information, consider customer ID, customer name, and customer address. So just customer ID in this table is the primary key, and next we consider the order table. So order ID, order date, and customer ID. In this case, order ID anyhow is the primary key, order date is a non-key, and what we are making here is maybe the same customer would have given the multiple orders. So what we are doing is the customer ID should be referenced as a foreign key in the order table, and this particular foreign key refers the customer ID in the customer table as a primary key. So we have removed the transitive dependencies. This is what how you can observe the third normal form. Any doubts, friends, with this? Please let me know so that we can move ahead to the next normal form. Actually, we have seen some different kinds of the normal forms, and now at the moment you are considering very good, Sandeep. And if you are considering the next other formats of the normal forms, we will be having the other normal form. Like, you know, friends, in the discussion itself, we observed various kinds of the normal forms. Okay. I won't give attendance, friends. If you are joining after 20 or 25 minutes, I may not give the attendance. Okay, be careful. Better you join class at least after starting of 5 minutes at least. The minimum things should be followed. Okay, all people are joining except one or two. I will announce the members who are all repeatedly late and who are all giving the disturbance. Okay, well, but first let me have some meaningful debate with the concepts, and we'll see, friends. All the many things were there. We'll see. No problem. Okay. First thing is concept, and then we'll figure out all the things, which are all the things, right? Okay, coming to the next thing. Actually, in the discussion in the starting of this normal forms, friends, so we are having various normal forms. So 1NF notation, and we are now into the 2NF, and thereafter we are having 3NF. Okay, so 1NF, simply I am writing, friends, so that you can remember easily. All attributes must be atomic. Atomic means single valued. Okay, and single valued. Okay, so just let me. And coming to the second normal form, fundamental condition is it should be in 1NF plus all non-key should fully functionally depends on primary key. Okay, so this is the second normal form. It should be in the first normal form, and it also satisfies whichever the normal non keys we are having. All those particular non keys must be satisfying. Okay, they should be fully functionally dependent on the primary key. And third normal form we are seeing now, friends, which should satisfy second normal. Already we have seen 2NF. Along with that, no transitive dependents are there. So here we can say fully functionally this is nothing but no partial dependency. No partial dependency. No partial dependency. Whereas if you are referencing the transitive dependence, okay, there should be no transitive dependencies. Now what we are seeing is just we are observing the stronger form of. Don't feel that this is a separate normal form, friends. Important. Okay, it is not a separate normal form. Stronger form of 3NF is the Boyce-Codd Normal Form, BCNF. Okay, so BCNF is which is nothing but it's not a separate normal form. But whereas if you want to refer, 1 minute, friends, if you want to refer sorry friends, and if you are referencing this BCNF, which is a stronger form of third normal form, friends, it's not a separate normal form, it is but it is a stronger form of the BCNF. Now why we need stronger notation? That already I have mentioned in the discussion of the thing. If you are considering any companies, friends, like Wipro, TCS or Infosys, anything, their stand is to come up with the good database design. And already in the discussion of the normal forms and normalizations, we have seen that to achieve the good database design, to achieve the standards and quality of the database design, we are having the notion of, okay, we are having the notion of the good design or quality design with the help of the normal forms. So normal forms and normalization is a process of achieving the good quality design while working with the database systems. One of the important aspect by the companies followed is up to 3NF, the general standard, friends, and if they want to maintain some other quality, if they want to be very stringent in the maintenance of the database tables and all these things, they can go with the some stronger form, which is nothing but the Boyce-Codd normal form. And one of the important aspect is very rarely, friends, very rarely the company selects the fourth normal form and fifth normal form. But whereas many of the companies are stop their normal form implementation up to the BCNF, because many studies shown that up to BCNF if you are following, then you can achieve the better database quality and design. So that's what they are not insisting on 4NF and 5NF. But anyhow, as per our discussion, if you want to learn in and out of this normal form, so we should follow the 4 and 5. That also we are going to learn. But only the thing is, in the reality, in the real time scenarios, one can observe that the usage of this 3NF, and if companies want to insist, they want to strengthen the appropriate third normal form, then the available normal form is the Boyce-Codd normal form. Okay, so BCNF is a kind of the normal form where you can identify the stronger form of the third normal form. Now we will discuss with the BCNF, whatever the thing. Okay, up to third normal form we have seen, friends. Now we are into the Boyce-Codd normal form. Let us have this, which meets all the requirements of the third normal form. That means no transitive dependency must be there, and in case of the 2NF, no partial dependencies must be there. In the form of 1NF, all attributes must follow the atomic. So those three definitions we are having. Any table is said to be in Boyce-Codd normal form. Just to observe here, friends, this definition is bit tricky because up to third normal form we are having very clear, like we are observing only the functional dependencies, but as already I have mentioned, BCNF is a stronger form of the third normal form. Definitely on the transitive dependencies it is going to talk, and it allows us to strengthen the third normal form. That's what the reason this definition is bit distinct when compared with the other normal forms. Okay, any table is said to be in BCNF if its candidate keys do not have any partial dependencies on other attributes. Okay, and one more important thing is minimum 3 columns must be there if you want to apply Boyce-Codd normal form, friends. Okay, now let us have a look. XY is a combination or composite key determines Z, and Z is only dependent on X, then it's a violation of the BCNF. Okay, already we have seen this, but only the thing is, if its candidate keys, what do you mean by candidate keys, friends? Do not have any partial dependency on other attributes. Okay, so whichever the attributes I am having, so, and if you are referencing, friends, if XY are the composite keys and XY implies Z, then there should not be any reverse dependency. Reverse dependency in the sense, so Z is used to determine X, which should not be happen, friends. Which should not be happened. Like XY is generating Z, so XY determines Z, but whereas in reverse order non-key is going to generate the key, so which is some kind of the combinations I will tell, friends, so that you can realize. Okay, observe here, friends, I am having key 1 here and which is generating non-key, it is acceptable, and we are having key 2 which is generating key 3, okay, which is also acceptable because both are having the eligibility of generating the whatever the unique records. Now observe here, friends, non-key is generating key 4, which is very dangerous, which should not be, and now what we are doing is, according to the definition, observe here, friends, key 5 and as well as key 6 are used to generate non-key some number 3. Now what we need to verify is, if this non-key 3 in turn may be defining either key 5 or key 6, then it should not be in it should not follow the, it is not following the BCNF. We have to resolve this. Hope you got the point. Very simple, friend, just to observe here, key 1 can determine the non-key, okay, allowable. Key 2 can determine another key, allowable, but this is which is dangerous combination, should not be, because non-key is something which we cannot depend on to generate the unique records, because it is not having any eligibility of generating the records without any ambiguity. Suppose if I am taking student ID, I can rely. If I am taking student name, maybe same students, okay, we may have repeated numbers, okay, like Sandeep is there, many, Ritu, okay, likewise we are having, if you are having multiple names, then getting the records and getting the marks or getting the attendance, all these things are ambiguous. So if you are observing any non-key is generating key which should not be, immediately you should resolve that. But here the case is bit distinct. How we are seeing this BCNF is, suppose I am having key 5 and key 6 which is generating non-key 3, for example, friends, we are generating non-key 3, and after careful observation what we have observed is, the again non-key 3 is generating key 5 or key 6. There is one kind of the observation we have seen in this thing, actually key 5 key 6 in combination generating the non-key 3, that is allowable anyhow, because from this point we can allow, because one key can generate the non-key, one key can generate the another key also, but one non-key should not generate key. And of course, one non-key, this is also not acceptable. This is also not allowed. Okay, so this combination we are not going to talk, because non-key we are not going to consider any functional dependency, because functional dependency talks about a key and as well as the non-key dependency. Now the question here is, friends, this is what you call the determinant, friends. This is the determinant. This is the determinant, and I am making you some column name. I am not designating that as key column, and what we are saying is it should be a candidate key. Observe here, friends, how they have solved the problem is, observe here. So while referring many combinations, okay, we are having some problem with left side entry only. Okay, left side entry only. If left side entry is correct, then you can observe the right side entry, no problem. Then what exactly the BCNF is doing is, whatever the table, whatever the attribute within that particular table, I am having some kind of the attributes. These attributes we are naming as a determinant, friends, which is going to determine determinant. Every determinant is a candidate key. Every determinant is a candidate key. How we are facing the problem? With the left side entry only. With the left side entry only. We are not having any problem with the right side entry. Maybe that right side entry might have the non-key sometimes or key sometimes, but our focus is on the left side entry, because this is the one which is going to generate the, without any ambiguity, I want to generate the records from a table, then definitely we have to observe the left side entry as a candidate key. Candidate key, we are all knowing. Candidate key is something like which is having the capacity of generating the records without any ambiguity, that we know. Every primary key is a candidate key, and group of candidate keys can be taken as a super key. Now the definition is, every left side entry, whatever the determinant I am taking, so left side entries, all these key 1, key 2, non key 2 and key 5 and key 6, all these are the determinants, friends. All these are the determinants, and these determinants must be candidate key. And if you are referencing this non key, which is not a candidate key, not a candidate key. Here also this is not a candidate key. Now I am just referring the example so that you can clear this BCNF. Now observe here, friends. Meets all the requirements of the third normal form? Yes, of course. Any table is said to be in Boyce-Codd normal form if its candidate keys do not have any partial dependency on other attributes, that is in the corresponding table XYZ columns. Now the thing is, XY, if you are considering the XY implies Z, okay, what it is showing, XY must be a candidate key, and of course if you are observing this Z is generating X, which is a clear violation of this BCNF, friends, because this is a non-key actually. So what we are doing is, if XY are composite keys and XY must implies Z, of course based on the combination of XY we are generating the Z, then there should be not be reverse dependency directly or partially. There should not be reverse dependency, like Z is going to generate XY, or Z is going to generate X, or Z is going to generate Y, which should not be there according to the process of the Boyce-Codd normal form. Let us have a look. One simple example I am taking, friends. Here what we are doing is student ID, major of the subject, and the lecturer, advisory lecturer. And anyhow the lecturer who are teaching is having the major subject. Suppose if you are considering my combination, I am dealing with RDBMS and I am dealing with fundamentals of the information security. So now you can easily observe who are all the, based on the names of the corresponding faculty, you can observe the major of the subject. Now the problem here is major subject which is a part of the composite candidate key is determined non-key attribute of the same table, which is against to the rule. Actually advisory lecture. So if you refer the student ID and major subject, these are all the composite key, for example. And I am we are observing based on the students. Suppose Ritu is there and some other Asim is some other side. Okay, Ritu is there and Sandeep is there. I am taking that student IDs and I am considering their major subjects. So by observing student ID and major subject, suppose you are belongs to B section and I am observing the corresponding RDBMS, then you can say okay, Dr. Uma Pawan is teaching this subject. But whereas at the moment I am taking RDBMS and you are getting the lecturer name. So if I am taking Uma Pawan, automatically it is giving the major subject. Okay, so which should not be happen, friends. Just with the faculty name, if you are getting the subject, of course logically it is correct, but according to the BCNF I am taking, as we are taking this example, and according to this particular example, what we have done in the earlier thing, xy implies z, but z should not be implicate xy or partial xy. But here if you observe student ID and major subject, which are major composite keys, and based on the student ID and subject name, I can easily tell whether he is B section or C section or whatever, whichever the section. Based on that particular ID only, I can figure out okay, he belongs to this section, and based on his subject RDBMS, I can say okay, he is the advisory member for that particular subject. But in the reverse manner, if you are considering this example, by considering the name of the faculty, we are going to get the subject name also. Just if you are giving my name, and my name would be in the B section and as well as the C section. In B I am teaching RDBMS, in C I am teaching FIS. Okay, so this is what how you can observe this table is in the not in the BCNF. So what is the problem here? Major subject which is part of a composite candidate key is determined by non-key attribute. Of course advisory lecturer can be used to generate the major subject, but our problem is not that. Our problem is this advisory lecturer is a non-key. It's not a key, because as per the definition, friends, whatever the content in the left side, this advisory lecturer which is the determinant, every determinant is a candidate key. That's what I am telling. If you observe the definition, whatever the column I am having the left side, that should be a candidate key. Then only you can achieve the proper results. Now you observe here in this particular example, as I am mentioning the advisory lecturer, and that advisory lecturer column is the non-key, and but one non-key is generating the partial key major subject, which should not be. So what we are doing here is major subject which is part of the composite key, composite candidate key, is determined by a non-key advisory lecturer which is a non-key, and which is against the rule of the Boyce-Codd normal form, which is against the rule. And what is the solution for that? Solution is this one you observe. And what is the problem? So subsequently we are observing the problems also, friends. Just to observe here, if we delete any student from the below table, it deletes the lecturer information also. And if you add any new lecturer or student to the database, it needs other related information also. If any update we are doing and the information need to be changed, else it will lead to inconsistency. Suppose if any update or if any student is changing from one section to another section, if faculty is getting changed, automatically it is reflecting. And now if you observe, friends, if I am talking about the deletion, this is the deletion anomaly, and if you are adding any new record, this is the insertion anomaly, and if you update anything, this is the modification anomaly. In the beginning of the session of this normal forms, we have seen these things, friends. Like just to observe, if you observe the anomalies in these things, okay, the main important thing why we are observing the normalization is insertion, deletion and modification. Actually the goal of this normalization is to avoid the insertion anomaly, to avoid the deletion anomaly, and to avoid the modification anomaly. Anomaly means here error, friends. Insertion anomaly in the sense adding new rows forces user to create duplicate data, that is the insertion anomaly. Deletion anomaly in the sense deleting row may cause a loss of data that would be needed for other future rows, and modification, changing of one row or changing of one particular value is creating the duplicate. The same thing we are observing in the BCNF. In case of this particular discussion, okay, just we are having any insertions, updations or deletions, it is causing some reflection. Actually we are having the lecturer information like student ID, major subject and as well as the advisory lecturer. Here student ID and major subject are the composite primary keys, and we are considering this advisory lecturer as the non-key. Okay, but what the problem we have faced, student ID, major subject are generating the advisory lecturer information, but the problem we found in this particular relationship is non-key, as we are considering this advisory lecturer as non-key, but still this non-key is generating the partial, whatever the key we are having, the partial key information, which is against the rule of the BCNF. So only the possibility just to observe here, friends. These things we can observe. If you need to add or update or delete any lecturer, we can directly insert record into the student advisor without affecting the student major table. And if you need to insert or update or delete any subject for the student, then we can directly do it on the student major table. We are having separate table without affecting student advisor table. And when we have both advisor as well as the major subject information, suppose I am having subject information along with the faculty information, then we can add directly, okay, add or update both the tables, since we have eliminated all the anomalies, rather than considering this kind of things, friends. Just if you observe these particular aspects, okay, lecturer as a separate thing, and yeah, because this particular lecturer is having student ID, major subject and advisory lecturer information, we faced some issues. So what we are doing is, so just we are considering these particular information into student advisor and as well as the student major. Like that we have taken two different tables, and if I am talking about the student advisor, it is having the information about the lecturer and as well as the subject he is going to teach, and student major anyhow it is he is having the information about the student ID and subject. Okay, so by doing so, just observe here the example, friends. We are having student advisor and student major as the two tables, and what we are doing is, in student advisor we are having student ID information and advisory lecturer, and in case of student major we eliminated this advisory lecturer from the student major, and we are only placing student ID and major subject. In this case, friends, the student ID determines the advisory lecturer, because based on that particular class I can say, okay, RDBMS is handled by so and so, FIS is handled by so and so, like that. Java is handled by some other lecturer. And similarly, if you are considering the student major, because that is only considering the student ID and major subject, of course you are in the third semester, you are having all these particular subject information along with the ID, and for the fifth sem students it is a distinct subject, and based on that ID you can easily clear these particular things. Okay, so this is what, friends, how you can observe the concept of the Boyce-Codd normal form. Our worry is, suppose if you are observing any left side entry, whichever the determinant I am having, every determinant is a candidate key. So based on that particular point, based on that particular formula, you can strengthen the third normal form. Okay, so the problem we observed here is, at the moment you are considering the appropriate information of the student ID, major subject and advisory lecturer, so there are certain anomalies we found, like insertion, deletion and as well as the update anomalies. So as to avoid that particular convention, we have taken two tables, one is student advisor and second is the student major. So by doing so, we can easily track all these particular information, and in a way we have achieved the left side entries, whichever the things we are having in the left side entries, all these particular left side entries becomes the candidate key, and there is no chance of generating a key with the help of the non-key. Okay, so that is what, friends, how you can observe the concept of the Boyce-Codd normal form. In the today's class, we started the discussion of the 3NF, and as well as we covered that 3NF and as well as the BCNF notations. Actually, if I am considering the third normal form, the relationship should be in the second normal form, and there should be no transitive dependencies. There we have taken the example of customer and as well as the order table, and customer table contains customer id, name and address, and the same customer id in another table we are managing as the foreign key, and we have seen the rules of the foreign key. And thereafter the another important point in the normal form discussion is there is one more normal form, friends, which is used to strengthen the third normal form. Actually up to third normal form you can achieve the no transitive dependency, but whereas the stronger form eliminates that. Sometimes there may be a chance of following these kind of the conventions, friend, which should not be, so we have observed some kind of the table, and we come up with one kind of the solution that every non key, whatever the left side we are having, while generating the left side keys must be candidate key. So all the left side entries that might be either key 1 or composite keys or whatever the keys we are following, these particular things must be in the candidate key zoner. So then we can